Hi friends, let's continue our discussion. Now let's see some of the reinforcement learning techniques. One technique is what we call cue learning. It's a value-based learning system. It is useful when the actions are discrete in nature. So the figure shows here a cue learning system is a table. This table has got two major columns. One column is a pair of state actions, and the other column is a Q value. So the system is in any of the state, and in that state, when any action is taken by the actor, then the state action are the two inputs given to this table, and from this table, the Q value is the output. So at any given state, our system tries or simulates various actions and sees the corresponding Q value for that particular action. And then finally, the action that gives highest Q value will be selected for the real action. So that is the Q learning method, and this method makes use of a Q table, and this Q table consists of all the state action combination pairs, and because all the pairs are to be listed in the table, so the finite size of the table is possible only when the system has got a finite number or a small number of states and a small number of actions at each state. Only then a handful size of the queue table is possible. But when we are dealing with a system where the number of states and the number of actions in each state is pretty large. In that case, it becomes very difficult to take any action. So we can't create any table. In such cases, we can make use of neural network, and we train the neural network such that for any given state, it provides the Q values for each of the possible actions. And here, the Q value for each of the action is the probability. So it tells the probabilistic version of the Q value for each action. So when we present a state to the deep Q learning system, then we get a n outputs summing up to 1 because it's a probabilistic answer, and the one action with the highest Q value here will be the most favorable action in the system should take. So that's about the value-based system. So in a value-based system, we can go for a queue learning if the size of the states and action pairs is small. If it is large enough, then it is better to go for deep queue networks. So that's about a value-based system. Next video, we look at what a policy-based system would look like. Thank you.